Let's talk G&M codes. We know that CNC means computer numerical control. This is where electronic systems are used to perform machine movements. G&M codes, often shortened to just G code, is the oldest coding language still in regular use today, and it all started with punch tape. Punch tape, like you see to the right, were strips of paper with the code literally punched into it, or more accurately, out of it. The tape was then fed into a machine that read the openings in the tape as the code a machine should perform. Later, in the 1970s, this same concept was developed into a more modern way of machine coding using computer chips instead of punch tape. A CNC machine, like the mill pictured here, moves via a program that is, still to this day, typically written in G&M codes. Just like any computer-driven mechanism, a CNC machine communicates using its own language. In order to communicate with the CNC, we must convert our language, things like turn this, move here, into one that the CNC will comprehend. Blocks of code are written in lines. The first thing you'll see in the line or block sequence is the block sequence number, represented as a capital N followed by a number. For our Tormach, we start with N01, though some machines may start with N00. After the block sequence number, we begin writing one of two types of instructions that exist. First one, those which define the toolpath, such as X, Y, and Z axis coordinates, and the second one, those which specify machine operations, such as performing a tool change. In this case, we would have to then specify what tool we would change to. So if an M is followed by a 6, or as we see in our example, a 06, the machine will expect to see a T for a tool, followed by a number. For now, we don't need to get into the specifics of this number after the T, but a machinist would have already instructed a machine to know information about the tool it has identified as tool 1. For now, we'll say this is all the code we want to provide for our first block or line. But we do need to provide a comment for the lines. And G code for our Tormach understands that you have provided a comment by using parentheses around what you're commenting. This is machine dependent, and some machines use other characters like a semicolon. So for this sample block of coding that we're using, we would then move to the next line. So we need a new line number, N02. For this line, we're going to turn the spindle on. We use an M03 for that. This is a miscellaneous code specifically for telling the machine to start the spindle, and in this case, turn it clockwise. The last thing we'll need to do is tell the machine how fast it should turn the spindle. S1500 is what we'll put in this example. And S represents spindle speed, and it's measured in RPMs. Moving on with this basic example here. For the third line, N02, we're going to tell the machine to use a prep code, a G code, that says we're going to enter either absolute or incremental, aka relative coordinates. If I want it to be on the same line, and in this case I do, I can then use another prep code to tell the machine to move in a straight line known as a linear or straight line interpolation to a specific X and Y and Z coordinate position and at a defined feed rate, in this case 1 inch per minute. Note this is an example of a program block and not a line of code that makes perfect sense in reality. More on that later, but note that you should not move X, Y, and Z at the same time. Before we can look at more examples of code, we need to know the basic terminology associated with G&M codes. We have an address character, a letter used to designate a class of functions like N, G, or F. We also have parameter, an attribute of a feature such as a dimension that can be modified. We have a word, which is when we combine an address with a number like G and 90 or M and 03. We have a block, which is a single line of code. Words put together in a line makes up the block. G-codes are preparatory functions that involve actual tool movements that control the machine. These include rapid moves, linear feed moves, and radial feed moves, and some others as well. Most G-codes are modal, meaning that they remain active until canceled or changed by another G-code. The format of the Go4 command can be found in a different format where P is used instead of F. The example here would be Go4 P2.3 is a pause for 2.3 seconds. But to be honest, we rarely use dwell or pause in our G-code experiences at our school. There are two methods for making an arc with G-codes. In a block or line of code, X, Y, and Z are used to define X, Y, and Z coordinates for the destination when cutting or moving in a straight line. However, I, J, and K are used to communicate the X, Y, and Z coordinates of the center point of an arc for circular interpolation. In absolute programming, which means that we're referencing back to the X, Y, and Z's 0 point for every location, I words represent the X coordinate, J words represent the Y coordinate, and K words represent the Z coordinate. This example shows the use of I and J as center point coordinates. Notice, for absolute, I start by defining or identifying my absolute coordinates with G90. Great. Then somewhere down the code, I go to the green dot. X is 1, Y is 2. Then I move to the blue dot by using the center point. On the same line as the blue dot's absolute coordinates, I also call out the I and J's X and Y coordinates. In incremental programming, which means that each new location is based on the distance from the previous X, Y, or Z location, i.e. relative coordinates, I, J, and K words specifically are for the distance from the start point to the center point of the arc. For relative, I call out the starting green location after identifying that I'm using relative. Then I go to the blue dots coordinates, which are relative to the green dots coordinates, by going around the center point, whose relative coordinates indicate that it is also relative to the green dot. Hence why it is on the same block as the end point. Both are relative to the green. IJ for absolute is located at coordinates x1, y1. Where I start cutting this arc is located at this green dot x1, y2, and where I end is this blue dot x2, y1. I make this arc in a clockwise direction, so I'm using a code to tell it to do so. Then notice that with relative, I have to identify that it's relative. The center point is relative to where my start of this arc was. Unlike with absolute, it's not just a location, It is relative to where I started. I started at x1, y2. That is relative to where my beginning of this program was, which is 0, 0, 0. It just so happens to also be that that first point for absolute and relative are usually the same. But then relative to where I started this arc, I stayed on x. I didn't move from x1 at all. I did, however, go down by 1 unit in the y. So my xy values for I and j are 0 for x and a -1 for y. That's on the same line that I have my endpoint for the arcs. x1, y -1 means that I moved over in x by 1 unit and down in y by 1 unit. x1, y -1. You may ask yourself, why is relative so useful? And down the line, you might find that if you make a mistake fairly early on in your coding and you update it and you change it, everything after it also updates and changes. But with absolute, although you can be very certain about the coordinates, if you make a mistake, you have to wind up changing a bunch of other coordinates. They don't update with it because they are not relative. Now, I and j do have their purposes and they are useful, but there is a second method of making an arc, and it's called arc with r. It's using an r radius. So the radius method is like this. It's very simple. I indicate how big the radius of the arc is with an r address character and a parameter value that equals the distance to the start or end point. In both absolute and relative, it's the same value. So it doesn't matter if it's absolute, I'm still using R1. And if it's incremental or relative, I'm using R1 because it's still just how long this distance is. What's the radius? And to keep things simple, the center point is still provided for us, even though it's just a radius, in the same line as the end point of the arc. So it would read as, I want to do a linear interpolation to x1, y2, and then I want to use a circular interpolation to get to x1, y -1 in relative, or x2, y1 in absolute. And I want to go around a center point that is located, in this case, 1 unit from this arc that I'm making from an endpoint or a start point. Okay, before we get into taking a look at some examples of how this will translate over to you making initials into a wax block or doing things more complicated, let's talk about a few other common G codes. These two, G20 and G21, are some that you might use a little more often. We will use G20 for this particular project that we're doing. It's inch programming units. So I would probably call out, since I'm using my Tormach, a G90, G90.1 if I know I'm going to use arcs and I'm not going to switch over to a relative system. And then in that same line, I could even call out a G20 and say that I'm also doing inch programming units. I can have multiple different groupings of G codes as long as they don't contradict one another in the same line. And then there's some other ones. Notice that these are all in the 80 ranges. So G80, 81, and 82 are all about various different things that pertain to one another. They come from that same family. I probably wouldn't want to use these in the same line as each other because they would, in some cases, contradict one another. So those are some other common G codes. There's a lot for you to investigate there. M codes are miscellaneous functions. We've talked a little bit about them already. They include actions necessary for machining, but are not actual tool movements. They're auxiliary functions, such as turning the spindle on or off, making a tool change, turning the coolant on or off, telling the program to stop. Here we see a pause. Now, we don't use pause very often in what we do, but it is or can be utilized as an M0. An M1 or M01 is an optional stop. We do use M02 quite often. That is end of program. I particularly also like to use, or instead of this, use an M30, which we'll see in a second. M03 is to turn our spindle on. M04 also turns the spindle on, but it turns it on in a counterclockwise direction, and we spin our tools in a clockwise direction. So M05 becomes the spindle off command, and M06, as you know from before, is a tool change. M08 and M09 for our machine specifically, if we're using it, turns the coolant on, and for our machine that is air and a manual adjustment if I want fluid to come out with it. So M08 would turn on the air, M09 turns that accessory off. If we have other accessories, we can program them into being M10 or M11, being on and off as well. Here's that M30 I mentioned before. This is a program end and reset. So it's like an MO2, but then it resets to the beginning of the code again. We can also use a rewind function if we know that we're doing a handshaking operation with some auxiliary system, something like a robotic arm or another machine, and we're utilizing our mill as part of an entire production or assembly line. We don't use M47 in our class for much at all. In fact, I think I've only seen this used once with our machine, and it was just as an example. Here are some code suggestions, just things that we think might be useful for you. You don't need to use the same code if it's just going to be repeated in every block. Machines will use that same code that you called out before until you change it. This is called being modal. In other words, if I know that I'm going to do a linear interpolation and I'm going to make it move at an F10, a feed rate of 10, and on the next line I'm still doing a linear interpolation, I don't need to call out that F10 again. It already knows that it's moving at an F. It's just like with the speed of the spindle. Once I called it out, it stays at that speed until I tell the spindle to stop. Once I tell it to start back up again, I will probably need to tell it to turn on at a particular RPM. Every line of code needs to have comments, so when I make these remarks, be sure to tab away from the code that I have so that I'm better facilitating my troubleshooting of that program. In other words, it's easier to see what's going on when those codes have their comments far away from them, or at least tabbed over away from them. Specify the absolute or relative coordinates and the inch or metric modes at the very beginning of your program, as soon as you can. In fact, if you can put them in the same line, do it. Always use a tool change command to move tools to a safe position that's away from the material, and then change the tool if necessary. Indicate your spindle speed each time you turn that spindle back on, if you in fact do turn it off somewhere in your code. And a few more. Move the tool to start positions in 2 lines of code. First, move your tool on the XY plane. Put in the commands for that XY movement, and then go down to the next line and move your tool in the vertical or Z axis. This prevents you from moving your tool 3-dimensionally and potentially ramping into material or inadvertently cutting into a part when you don't mean to. So one of the safe practices here is to move your tool over in X and Y, move to a safe position above the material, and then slowly plunge your tool into the material and then start moving in the X and Y. All of that happens on different lines of code. Raise your tool out of the stock at the end of a program. Don't just do an MO2, stop your program, and have your tool still in the stock. Bring it up out of the stock. You're going to completely move it away so that you can get into a safe unload position, and then turn off the spindle and end your program. Use either an MO2 to end your program or an M30. It really doesn't matter. The M30 resets your program if you're going to be using this again. So if I know that I'm going to come into the lab and face mill a bunch of wax blocks over and over and over again, I'm just going to build in that M30 reset so that it's just ready to go again and doesn't just end my program. Over the next few slides, I'm going to show you an example of initials in a wax block. We're going to use these MD initials that you see here that are labeled with A, B, C, D, and E for the M, as well as the points F, H, and a center point I for the D. Notice that the absolute coordinates have been provided in a table for each one of those points. Very useful thing to do, which is why you'll also be doing it. The picture also identifies where the origin is, or what's known as 0, 0, 0. For our purposes, we know that we're going to plunge into the material by about 1/16 of an inch, and then we're going to start cutting. We don't plunge until we get to point A, though. We still need to know where 0 is, so we do some processes before we start running the code to identify that 0 point. Now on this slide, I'm going to walk you through the actual G-code blocks or lines of code with the comments provided as well. So remember, the characters between parentheses are ignored by our machine, and though some machines prefer semicolons, for ours it's all about those parentheses. The space between those parentheses is where we will put the comments, and they're important in any programming that you might do to document the purpose of each line so that the original programmer can troubleshoot, or so that any other person working with the program knows exactly what was intended for that line. Okay, line 1, we see that they're turning on the absolute coordinate program and they're saying turn on inch mode. For our Tormach, we would also have to put in a G90.1 because we do have an arc in that D. And so it needs to know as soon as possible that you have not only absolute coordinates for any linear interpolation, but also absolute coordinates for any arc or circular interpolation. And we know that we're using the inch mode. I would technically put M06 and T1 on that same first line, but PLTW is playing it safe here, and they're providing for us a little easier way of reading through the comments. So they've put on line 2, which is fine to do, a tool change. M06, change it to tool 1. Then they say turn the spindle on in a clockwise direction and spin that thing at 3,000 RPMs. Great. I would do that on a separate line so that I don't turn it on as soon as I've grabbed the tool. I'd get the tool, I'd make sure the program knew that, okay, next I want you to turn it on, but you could technically do this. You just don't want the machine to make a mistake if it does and start spinning before it grabs the tool, especially with ours since it uses an automatic tool changer. All right, now I start moving this tool around. I do it very quickly. I wrap it over to point A. I'm at my origin. I go to point A and I say, go down. But I tell it to go down quickly. I tell it to rapid to the part, just above the part. So currently I'm very much so above wherever the tool loading position is. For PLTW, this is probably like 2 or 3 inches up. For us, it's pretty far up because our tool changer is at the top of the machine. So we rapid down to 1/10 of an inch above the part. This can be a little nerve-wracking. Then, once we're there, we go slow and we plunge through the 0 point and into the material by 1/16 of an inch. So this is a negative 0.0625 in the Z direction. Note that I have changed my G code and I've changed my feed rate. In fact, I haven't changed my feed rate. I've identified a feed rate. This is the first time I've identified it. With G0s, I don't need to identify a feed rate. It goes as fast as the machine can make it. But G01 indicates that I do need to have a feed rate, and I want to go at about half of what I normally would. Now, for our Tormach, you can go through wax pretty quick. I usually run it at around an F10, but F9 is totally acceptable. Then I would say continue along in that linear interpolation, only now move in the XY direction. I think technically you can get rid of the G code part here, get rid of the G01, but you do need the F18. So I typically do go ahead and provide that G01. I've sped up the feed rate now, still spinning at 3,000 RPMs, but now I'm moving that bed, moving that material through the tool at about 18 inches per minute. And I'm moving now to point B, which if you look at the table is 0.5 in the X and 1.5 in the Y. I keep going. G01, okay, it knows that I'm using a G01. I do technically just have to call out the X and Y, but again, it's a safety kind of thing that PLTW is providing here. So we go with it. We move to line C, line D, and then line E or point E. So we've made all these lines going to these different points. The M initial is now carved, but I've got to come up out of this particular piece of material, and I'm going to do so with a G01. I'm not going to wrap it out of it just in case something weird happens. I'm going to come up out of it at whatever speed I had the feed rate set at, which in this case was still an F18. So I wrap it up to a 0.1, 0.1. Z is now 1/10 of an inch above the material. The tip of that tool is out of the material. I've retracted it. I can now move it. As long as this material is nice and flat and I'm not going to run into anything else, I would wrap it over to point F. That is the point at the top of the D. And its coordinates are 1.75 in the X and 1.5 in the Y. I then have to go back down into the material, so I do a G01, a plunge in the Z direction through the 0 point and down into the material by a 1/16 of an inch. Again, I have to identify a new feed rate because not only did I use a G0, but the last feed rate that I put in with a G01 was an F18. So I call out the F9 and then I start moving. Have to go into an F18 feed rate because I'm now not engaging with a plunge, but rather a straight line interpolation, and I would just be wasting time if I didn't speed up since I know my machine and material and tool can handle this. I go to point H. So I've gone from F straight down past that center point for the arc to the bottom of the D. To get that curve, I have to go in a counterclockwise direction. So I use a G03 and I go back to the F point. So my X and Y now are the absolute values for the F point again, but I have to provide the center point at which they're going to go around. Since I used the G03, my machine is going to look for either an IJ setup for the center point so that it knows where that center point is located in the X and Y coordinates, or it's going to look for an R character followed by the radius value. So counterclockwise circular interpolation going from the H back to the F around the I center point. I get there and I come back up out of the material. So I am now in a retract position. I've retracted the tool to a fairly safe spot above it. This is the same spot at which I would feel comfortable rapidly moving around the top of my wax block that's nice and flat. But I do go ahead and tell it, turn off the spindle. So I got to be careful here. I don't want to run this tool now into the material at all because the spindle has stopped. When it stops, I then tell it, go to a safe position above the material and do it quickly. So this is just kind of stepping it away. This is saying come out of the material and then stop the spindle and then move to a safe location above it. In this case, 2 inches above the material. And then you can go ahead and move the bed. Remember, don't move Z, X, and Y all at the same time. Then move the bed so that I can unload the material and unload the tool if I need to and put in a new block or a new tool if necessary. This is also around the same time that I would run an M30, or if I knew I was going to be changing the tool with the ATC, I'd give the command for changing the tool and it would move through that process. But for this simple product or project, we're now done. We have ended the program. So what does this look like if I write this G code with incremental or relative? Okay, same thing. Word means the same thing. Same block, same letters, same positions. We're just thinking of the points as being relative to each other as opposed to something that is an absolute value from the origin. All right. Even though I am going to run a relative or incremental, I need to think about the fact that to get to the origin point, it's probably a good call for me to run this in absolute at the moment. Also, since my rapid is going to be something that I want to do quick and not inside of material, and something that I'm going to use to get over to point A, I really don't have to change over to incremental coordinate systems until I've gotten to that point. So I'm going to start off my incremental by being in absolute coordinates in inch mode. Inch mode is important there. I don't technically need to put in a 90.1 here because I know I'm not going to do any arcs with the absolute. I do need to do a tool change. I do need to turn my spindle on at 3000, and then I need to move over to point A, and I can even wrap it down to being just above point A. All of that being in absolute coordinates. So it knows I am 0.1 inches above the material. Then I switch over. Then I do add the 91.1 along with the 91 for the incremental coordinate system. I don't need to call out the inch mode because it's already been called out. Now pay attention to this. I am 0.1 above the material. I need to go through the Z. I am not telling it to go to an absolute position. I am telling it how far to travel. I am currently at a Z coordinate of 0.1, positive 0.1. So I need to travel a 1/16 of an inch down into the material, and the material is still a 1/10 of an inch away. 1/16 of an inch is 0.0625, and a 1/10 of an inch is 0.1. So I have to go from 0.1 and move that tool down by a 0.1625 amount. I'm not going to the location 0.1625. I'm going by that amount. That is the difference between absolute and relative. It is relative to where I was before. So I am now located, if I thought of this as absolute, at the negative 0.0625 position, just like I was with the absolute setup that I saw before, but I had to travel that additional 0.1. So negative 0.1625 is my relative or incremental distance to travel with an F9. Stay with that G01, and now I move. Note what my coordinate system table says. Once I go from point A to point B, I am staying on my x-axis. If I look, B is directly above A. I haven't moved at all from that X point. So X doesn't change. X stays at 0, but I do go up 1, 2, 3, 4 quarters, or an entire inch. So a positive 1, which is why I have X0, Y1. It's relative to where I was when I got to this location at point A. I'm doing this for whatever reason. PLTW says F16. Honestly, I'd be running this at about an F20 or higher because it's wax and our machine rocks. So I go to point B with a straight line interpolation, and then I go from B to C. Now B to C does change in both the X and the Y. In the X, it's going to be a positive value, which tells me when I look at this table, I'm moving to the right. I'm moving to the right by not just a 1/4 of an inch, but a 1/4 of an inch plus an 1/8 of an inch, about halfway. And that's 0.375 inches that I've moved to the right. And I have also gone down by 2/4 of an inch, or a 0.5 in the Y. So this negative means from where I was last time, I've gone down. This positive means where I was last time, I've gone to the right. I continue to the right as I go back up. So my Y should be a positive value, and I went back up 0.5. And all of that is indicated here in N9 and N10. I'm still moving in a straight line, so nothing's different there. As I get to the D and move down to the Y, my X has not changed, so it stays as X0. X0 here for E, and my XY is now a -1. Very similar to what I saw for B, only instead of going up with a +1, I'm now going down with a -1. All right, this takes us on to N12, where I have G01, and I'm coming up out of the material. Keep in mind, I don't need to go to point 1. I need to travel by the same amount that I went from that point 1 position down into the material, but the opposite direction. So instead of going down another 0.1625 with a negative value, I'm going back up by 0.1625 with a positive value. This has retracted the tool and put it at a position of 0.1 above the material. So got to remember, although I am at an absolute place, I am only thinking of these terms as being relative. So these values are relative to one another, not to where I am in an absolute location. Moving on. I now need to rapid from E, now that I'm out of the material, over to F. I can do that because I'm not in the material. I go down into the material with a plunge. Notice that it is the opposite of the 0.1625. It's now a negative. I have to travel by that same amount to plunge back down. I have to change my F back to an F9 because for the purposes of a plunge, I'm engaging the tool into more material, so I go a little slower just to play it safe. Then I move from F to H. I did not move on the X, so X stays as a 0. I did go down by an entire 1 inch, and I can do this at a faster rate. And again, remember, our Tormach can go through this wax pretty quick. I'd typically do around an F20 here. And I'd run my plunges and curves at around an F10, but you won't see that they do that for their circular interpolation, which is what they do next. They get down here to the H, they go around that D, whoop, and they run it at the F16 that they've got set up right now. And that's probably fine to do for what we're running through. Wax doesn't really hurt our machine all that much, or at all, to be honest. Notice that this is relative here to what I had before. I am not moving from the X position. I'm going to go from H back to F. So I just went from F straight down to H, but now I'm going to go back to F. I'm just going to do it by going in this arc. And although while in that arc, I do travel to the right, I'm ending back at that F. So my X hasn't changed. It stays as 0. I'm going to end right back above where I started. And in fact, right back where I came from, right? So Y of being 1 inch above. So I came down, and now I'm going to go right back up to it. The trick is I'm running a G03. I'm running this as a counterclockwise circular interpolation, and I have a center point relative to where I started. Okay, so note this. I is my center point, and relative to where I started moving, okay, which is H here. To get back to F, I have to go around a point that is relative to H. So I is 0, but H is half of an inch, 0.5, 2 grid lines, further up in the y-axis. So this is relative to where I was for point H. I've brought my line down, and then I curve it. Then I get to F again, and I pull the tool out. I do just a linear interpolation, bringing the tool slowly back up. This is running it at F16 because, again, when I'm coming back up out of the material, there's nothing for my tool to engage into. It's just a safe thing not to do it as rapid. Then I tell it to turn off the spindle, just like I do before. I change it back to absolute coordinates, and I tell it go ahead and run a Z2. Again, for us at this point, I'd be running an M30 because that tells our machine just, you've come up out of the material, take it back to the safe loading position and reset the machine. You can do this if you'd like, G0 to a Z2, and then G0 to X4, Y3. Again, these are going to be in the absolute coordinate positions because I've changed that prep to a G90 and out of the G91. Then once I've got it there and I'm ready to be finished, I end my program. Okay, I'm hoping that this makes some sense to you, and if not, pause the video or go back and take a look at a couple of things. If I were to go back and look at that last example, what line used the arc command? Well, N16. N16 used the arc command, but it used it with an I and J. What I really want to do is make that easier and change the arc command in that last example into something that uses the R command for a radius. That would look like this. N16 G03 X0 Y1 with an R.5 for a counterclockwise circular interpolation. Here's what it would look like if I did actually put it into the code itself, and there is my R.5 instead of the I and J. All right, let's explain what each of these words in the code means. Here I have N02, G01, X2.5, Y3, F2. I can actually slam them all together like that as G code. The computer doesn't care. It's going to pick them up just fine, but for you, for organizational purposes, it's probably best to keep them somewhat separated, as we've been showing you moving down the examples that we've been doing. So what is this one here on the far left? We should know that this is block 3, and that this G01 means at this point you should know a linear interpolation or a straight line interpolation. And then for X, 2.5 on the X-axis, 3 on the Y-axis, and a feed rate of 2 inches per minute. Now we can also assume at this point that because it's 2.5 and 3, we're probably running a G90 and G90.1. So we're running something that is absolute coordinates. Otherwise, this 2.5 would tell me to move by a 2.5 amount, and this would tell me to move by a 3 amount. We can also assume that we're running G20 because we're dealing with 2 inches per minute, and IPM, that's inches. Let's take a look at what's wrong with each of these. Here's the first one. Can you identify what it is? Here's the second one. Can you identify what's wrong with this one? Here's the third one. What's wrong with these lines? Fourth one? And the fifth one. Pause the video, take a minute. In number 1, this example includes 2 X codes. The use of 2 G codes, however, is correct because one G code is from the interpolation group and the other is from the programming mode group. I would recommend to you, though, that before you tell it G01, you do put the G90, and probably not even put them on the same line. It should work, though. The second one. This example uses 2 G codes from the same group. I'm telling it to wrap it and to do a linear interpolation. It's not going to like that. It has to be from 2 different groups if I'm going to use 2 G codes. Number 3, this example is not really wrong. It's just unnecessary. You don't have to repeat the feed rate, the linear interpolation, the X value code in the line in 4 because they remain the same. And that's tricky for students. I'm not going to say that this is wrong to do. I'm just going to say it is unnecessary. You're not being as efficient as you could be, but it's playing it safe. Number 4, there's nothing wrong with this example. It is okay to take out extra zeros. So here I have N06, G00, X0.5, 0, 0, and Y 1.500, and I changed that from that to N06, G0, X.5, and Y 1.5. I could even take out this 0 here and just say that it's N6. I tend not to, though, with the number lines. Helps keep everything in line, and I mean vertically in line whenever you're looking at your code. Keeps it clean. For number 5, there's no such thing as a G9. The Z value has changed from 0.05 to 0.5, and the M address character has been left without a parameter. So that's an issue, changing from N02 G90 Z 0.05 with an M00 to an N02 G9 does not exist, and a Z of 0.5 has changed from 0.05 to 0.5, taking out too many zeros there. And then for the M, there's no number. Okay, that is G code in a nutshell. I hope that this has been somewhat useful in helping you be able to come back through this information and get this all correct for your project. Good luck.